Hello everyone, welcome back to the another session. This video will be going to learn about performance measurements of an algorithm, and this topic is from unit 1 and the third topic. So the title is giving you a knowledge that we'll be going to measure the performance of an algorithm, and this will be measured by using two factors, which are space complexity and time complexity. What is space complexity? The amount of storage space of an algorithm takes to solve a problem. So that is what the space complexity. And space complexity will be calculated based upon a formula. The formula is what? Space complexity of a problem is equal to C plus SP. C is what? Fixed part variables. SP is what? Variable part variables. Fixed part variables are which doesn't depend on any other variable. Example, constants, input and output independent statements. Variable part is what? It depends on other variables. Now keep this formula in the mind. Now here we go with the example. So look at this example. In this example, you can find it what are fixed part variables. Fixed part variables are what? X, Y and Z. Variable part we did not find in this example. Hence, S of P is equal to C plus SP. So SP attribute is not mentioned. C value is 3. What is C value? Fixed part variables. So how you can get this 3 condition? If each variable contains 1 unit of memory. Hence, S of P is equal to 3. Now, look at the second example. This example, we wanted to calculate sum of array elements. So here you can find out fixed part variables and variable part variables. Fixed part variables are what? You can see as A, N and total. A is your array, N is your highest index of an array, total is the third variable. These three variables are not dependent on anything. So in the place of C you can write 3. Now what is SP? SP is what? Variable part. Variable part is what? How many times this statement will get executed. See, if I wanted to execute this for single time, that means what? Single time execution storage space is required for this. So likewise, how many times we do it for n times. So finally, space complexity of this is what? 3 plus n. Now we'll see the other example also, recursive algorithm. And this recursive algorithm will take 3n plus 1. That is 3n plus 3. Okay. Now, so in the three examples, space complexity will take some notation in the form of a function. Okay. And those functions are asymptotic notation functions or big O notation, omega notation, big O notation, omega notation and theta notation. So in these three cases, scenarios or asymptotic notations, we will be going to take one sort of function into our algorithms. And this is what? Time complexity. Space complexity formula is what? SP is equal to C plus SP. Time complexity is what? The amount of time which is required to store this algorithm implementation part. Now those are methods to calculate time complexity, that is measuring time complexity, which is line count and operation count. In order to calculate time complexity, we use frequency count or step count and operation count method. So now you can see here frequency count. Now what is operation count? Every algorithm will have some basic operation, maximum execution time to solve a given problem. So that is what line count is what? Frequency count. Operation count is what? How many times we will get execute. So here is an example to understand much more. Maximum algorithm is that. So in this, what is basic operation? And this is what basic operation which takes comparison operation, because that is what basic operation. If you look at this algorithm, max is equal to a of 0, that is not an basic operation. What is basic operation? Basic operation is the operation which is having comparison operation. So now here we go. Space complexity of this is what? You have to count how many variables. So now let's see how to calculate time complexity. The product of basic operation and line count against to n. That is what the formula of time complexity. Now T of n is equal to B into C of n. What is this B? Basic operation. What is the C of n? Count against to the algorithm. So finally 1 is what? It's a dependent variable. So that is what 1 dot n minus 1, which is n minus 1. Now let's see how to calculate frequency count method. So this is what important. For comments declaration, step count is 0. For written and assignment statement, step count is x equal to 10. Consider higher order exponential way. That is what? When you given with these kind of things to calculate frequency, now you need not to worry about it. You just take the formulas out. That is what? This is x power 4, x cube and x square. So when you have highest degree, lowest degree will be keep quiet. Now let's see the here some problems we were mentioned. The problem is what? Square matrix calculating the time complexity. So here it is having 2 for loops because it is square matrix. To execute this we required n plus 1. To execute this we required n into n plus 1, because this loop will get repeated for n times. That's what n into n plus 1. Now this statement also will be executed for n times. So finally the time complexity of this is what? 3n square plus 3. This is what? N square. 3n square. So in the previous video we were discussed about this, that when you have highest polynomial degree, you need not to consider those rest of the things. So it is n square. Finally the time complexity of this algorithm is what? Big O of n square. So that's it. Thank you all.